Hello all, welcome to part 30 of the Wireless LAN Security Mega Primer. In this video, we will understand EAP MD5 and go ahead and create a full demo lab for simulating that for our experiments. So very quickly, how does EAP MD5 work? Now, you have a client, an access point and the radius server. And I think most of this you would recall from the basics of WPA Enterprise, where you have a supplicant, an authenticator and an authentication server, right? So the first thing which happens is that the client is requested for its credentials or for its identity to begin with an EAP request identity packet, to which the client responds with a response identity packet, which is forwarded and encapsulated in a radius packet to the radius server. Then there is a challenge exchange, which is an MD5 challenge from the radius server to the client. The client responds back to the challenge, and then finally, depending on if the client knows the correct password and the MD5 hash is correct or not, the radius server sends either an EAP success or a failure. Now, we will look at how each of these steps happen in a very fine-grained way. So bear with me here. Don't worry if the whole slide and everything was a little bit quick. We'll go through every step which is happening on these slides. So the first thing we need to do is set up the radius server with some appropriate configuration for EAP MD5. Now, EAP MD5, you would require a specific username and password to be set on the radius server, using which the client would authenticate, right? So how would we do that? So let's go to our backtrack instance. Now this backtrack instance is up and running from the last video as is, nothing has been changed. The first thing we need to do is go into this directory, user local etc raddb, and inside that let's first create a backup copy of the user's file. We'll do this for almost all our videos simply because you're going to change a lot of things and you would ideally want to go back to the original configuration if something goes wrong. So let's open up the user's file, and what we are going to do is add just a simple line here which would define a user. So the way to define a user is, let's say the username is security tube, and then we define the clear text password for security tube. Basically what we are doing is just copying this line with whatever we want here, right? So let's say demo 12345 is the clear text password. This is the first thing we need to do. This is the username and password the client will authenticate with. Now let's go back to our presentation. The next step is to go ahead and make EAP MD5 the default EAP type. Now, the important thing is that EAP MD5 nowadays is almost never used in wireless because it is insecure and because of other important things like it does not provide mutual authentication and many reasons. Now, Windows has done away with EAP MD5. In the sense, with Windows 7 you would not find it available anywhere. With Vista and below, you could go ahead and enable it with special registry settings. But basically it's been discarded for lack of security and other important things which you would want typically an EAP technique to qualify. So, but the interesting thing is that you could still use the WPA supplicant utility on Windows or on Linux to use EAP MD5. Now, what I am going to be doing is on the Mac, you can actually go ahead and configure the client to use EAP MD5, and this is what I will be doing. Anyway, so the basic thing we need to do is make the default EAP type, which typically on the radius is PEEP, which we will come to in a later video. We need to set that to MD5. So let's first make a backup of the eap.conf file. And then let's open up the eap.conf file, and if you notice, we have MD5 clearly mentioned here, which is all great. What we need to do is just kind of, let's go ahead and change this to MD5, right? This is the second modification. Third modification is to ensure that the shared secret, which was test, if you remember in the last video, between the client, between the access point and the Radius server is all set. Now, if you want to check where that configuration option is, it is in clients.conf, and because we are using the 192.168.0.0 subnet, the shared secret is test, which has been fed into the access point so that it can itself authenticate to the Radius server. Now this is going to be a long video, guys, so hang on, this is not going to be easy, right? And this is where we fed that. So this is the configuration options you require to enable EAP MD5. Now what we could do is we could start the EAP server, but before that, Radius server, let's go back to the PPT. Now what is the objective of this lab? Now the reason I have chosen EAP MD5 is it is first of all very easy to set up. Second, we will slowly look at various EAP types after this, like PEEP, EAP, TTLS, etc., which may be used in wireless, and look at various insecurities which are there, and even do demonstrations wherever possible to exploit those insecurities, right? But in this lab, the whole idea is to quickly go ahead and understand how WPA enterprise functions on the wireless side as well as on the wired side. And this is where what we are going to do, as always, is use Wireshark to look at each and every packet on the wired side, which is the traffic between the access point and the Radius server, and then eventually on the wireless side, which should be the client, which is my Mac laptop, and the access point, right? And if you remember, my little handy access point is here. Okay, so how have we architected this lab? Now, as you can imagine, this seems to be a large setup, but interestingly, you can go ahead and do this on a single backtrack machine itself. So here is what I've done. My backtrack VM is running on my Mac, and basically I have created an ETH0 or an ETH1 interface, which is actually connected to the wired LAN. The wired LAN is nothing but a cable running from my laptop directly to the access point, as you can see here, right? It's this cable. And basically we are going to run one instance of Wireshark which is going to monitor this interface. The other interface is a wireless interface which you will create on the backtrack VM, where there will be another instance of Wireshark running to monitor the wireless traffic on the channel on which the access point is broadcasting its SSID security tube. Now the client software is basically the Mac OS system which I am on currently. So I would use the the host operating system to go ahead and simulate the client, and I would use the guest, which is the Backtrack 5 VM, to have the free Radius server and also to monitor the air, right? So hope this is clear. Now my Backtrack instance is already up and running, and I have the ETH1 interface which is all up, already has an IP address. I could just ping the access point through that interface, which is at 0.1, to ensure it's up and running perfect. Please note, depending on your access point, this IP address would be different. Even the range of IP addresses allocated may be different, in which case you need to modify the clients.conf file accordingly. Okay, perfect. So now let's go ahead and start our Radius server. So the Radius server is up and running now. It's listening currently for requests. And what we are going to do is, let's start two instances of Wireshark. This would be instance 1, and this instance would be sniffing on ETH1 interface. and what we are looking for is EAP packets basically, right? Now let's also go ahead and create another interface, which is going to be our Mon0 interface, right? So if you notice, currently we don't have our wireless card being listed simply because our handy little alpha card is not connected. Let me connect that, and in a bit we should see our WLAN 0 interface show up here. I think I may not have configured devices to have this card enabled, so let me go ahead and do that. Okay, I think the alpha card is being recognized. Perfect. Let's start Airmon NG to create our Mon0 interface here. And the first thing we are going to do is locate our access point, which is security tube. Oops. Arrow dump Mon0 to locate our access point. Security tube. Perfect. This is where it is. And what we are going to do is, let's just set the channel to that of the access point. So we have iwconfig Mon0 channel is 1. Perfect. Now let's launch another instance of Wireshark, and this instance would be sniffing on the Mon0 interface, right? So there's going to be a lot of excessive traffic here, but what we are interested in are the EAP packets only. Perfect. So now we have one instance of Wireshark, as you can see, sniffing on the wired interface, and one instance on the wireless interface. If we were quickly to visit our slides, the wired interface is going to be all the packets between the access point and the Radius server, and the wireless interface is going to be all the packets between the client and the access point, right? So the packet sniffing is all up and running, and so is our Radius server. The username we created was security tube, and the password was demo12345, right? Let me just yes, okay. So let's go ahead now and start an authentication request. So for that, we'll go back to our host system and connect to the security tube network. Now I've already created, if I kind of go to the open network preferences option, right, where what I've actually done is that I've already created a very simple profile called Vivek, and what I've really done is I've just set the authentication to MD5, right? So you could do that on your Mac system as well. I leave this to you. It's very simple task. And now let me go ahead and connect to the security tube network. The moment I would do that, if you notice, it actually says authenticating to network security tube, right? Which you immediately know that this is .1x based authentication. I think the password was demo12345. Let's see if this is correct. Let's go back to our client machine, and if you actually look at it, there would be a lot of traffic which is going by, and it says, you know, access request for username security tube, blah 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 blah, and basically you know, we have a dump here. But let's try and understand what happened. So first, let's look at the wireless interface. Now the wireless interface is basically akin to all the traffic which is going between the client and the access point. And if you notice, there were a couple of packets which we expected. The first was the request identity packet, which went from the access point to the client, right? You could probably stop sniffing on both of these. on both the wireless as well as the wired interface. And let's go back to the wireless interface. So the first EAP packet was from the access point, the D-Link access point, to my Apple MacBook Pro machine, and this was an EAP request identity packet. So if we just quickly open up, you would see that this is a request identity packet, right, as we had expected, and the client responds back with a EAP response identity packet, in which we can see that the identity is security tube. Now, as one has probably already guessed, just by monitoring these response packets, you could do user enumeration on the network, simply because these packets are all in plain text. Anyway, after that, the client, the access point, goes ahead and sends the MD5 challenge, which it has received in turn from the Radius server, right? And to that, the client goes ahead and responds back with the challenge response, and then finally the access point sends the success packet to the client. Now, if we were to just go ahead and look at what is happening on the wired side, you would notice something very, very interesting. And this is where, let's go ahead and put this up here. The first packet on the wired side is basically the Radius access request, which is sent by the access point to the Radius server. Now, this typically happens when the client goes ahead and sends the EAP response identity packet. Now, let's go ahead and correlate this. The first packet is the EAP request identity packet, which was sent by the AP to the client. If we go here, I'm just hoping we've been able to capture all the packets. This is that first packet. The second packet is the client responding to the access point with its identity, as we see here. Then the access point sends this entire packet to the Radius server using a Radius access request packet. Now, this is exactly what we see on the wired side, which is the first packet, right? And within this packet, you actually see the EAP kind of being encapsulated with the response from the client, which is the identity response, and which has the username security tube. Now, going back here, the Radius server responds back with an EAP request MD5 challenge packet in an Radius access challenge packet. So if we go back here, you will notice the second is a Radius access challenge packet, which is going in, right? And what we see here is basically that this contains the challenge, if you notice, which in the next packet is relayed by it back from the access point to the client. So if you just quickly look at the challenge, the value will have to be the same. So it says 5D08 and ends in 7F1. If you go to the wireless side, you would see exactly the same thing in the packet between the access point and the client. The client now responds back with its response to the challenge, which is what we can see here, 2C30D blah blah blah, and this is relayed back from the access point to the Radius server, exactly here, 2C blah blah blah. And after this, as expected, if the authentication succeeds, the Radius server sends the EAP success packet in the access accept Radius packet. Here it is, it says success, and this is relayed back to the client on the wireless side with an EAP success packet, right? So this is how, by looking at the wired side as well as the wireless side, we are able to decipher what is exactly happening over the air. Now, just as an example, if we did not have the right credentials, you would see that this would break up early on, right? So let me go ahead and start sniffing once again. And let me go back to the host machine. Let me just disconnect from this network momentarily, just by joining to another network maybe, and then go back here, connect back to the security tube network. So here goes security tube, and now I'm going to put in something arbitrary, probably something long, definitely not the actual password, right? Now if we go back here and if we look at the dump on the Radius server, you would actually notice that a reject has been sent, right, where the authentication has failed. Now what we can do is we could just go ahead and open up the wireless side, and if you notice on the wireless side, well, you gotten a couple of packets here, because what is typically happening is that the client would try multiple times as failures happen, but the key thing to note here is the EAP failure packet, which is eventually sent from the access point to the client. And on the wired side, you would actually go ahead and see a Radius access reject packet, which is where the Radius server says that the authentication has failed, right? Perfect. So coming back here, so I guess that's all I had in mind for this video. What we've looked at is how we can go ahead and use EAP MD5, even though probably it's not really used in any Wi-Fi network anymore. Create the entire setup, create a very simple demo, use your laptop to connect to that EAP network. Please note, apart from Windows XP, and that too like the very first home edition probably, nothing else supports EAP MD5 by default on Windows, right? But you could use WPA supplicant and other tools to probably make it work. On the Mac, it supports, you can create a profile with EAP MD5 and it just works. I guess one of the good things of probably having a Mac, but maybe not, because EAP MD5 is insecure, so I don't, it should never be used over wireless. Anyway, please leave your comments behind. In the next video, we will look at how to crack EAP MD5 using Joshua Wright's tool called EAP MD5 Pass, right? Okay, enjoy, leave your comments behind, and if you like this video, if you like what we are doing, please donate. That is something which is going to, help me fuel more of my time into the Security Tube project. And as mentioned, all videos will be free of charge, forever available to everyone. Thank you and bye-bye.